Good morning, everybody. I'm from mechanical engineering. Today, I'm explaining about fuels used in an IC engine and grids. Myself, KVJ Kumar. I'm from mechanical engineering. Introduction to IC engine fuels. And internal combustion engines (ICA) rely on specific rules for operation. Understanding the types of fuels is crucial for engine performance. This presentation explores various fuels and their grids. Here we see to the fuel energy distribution. And brake power 35% and radiation 5%, cooling system 30%, exhaust 30%. And we have the radiation is the lowest thing in the fuel energy distribution, and brake power is 35%, and so cooling system is 30% and exhaust is 30%. Here we to know the internal combustion engine rely on fuels for operations. The types of fuels is crucial for engine performance. Radiation, brake power, cooling system, exhaust systems. The presentation exports various fuels and grades. Types of fuels used in an IC engines. Fuels for IC engines are primarily classified into gasoline, diesel, and alternative fuels. Each fuel type has distinct properties suited to different engine designs. The choice of fuel affects efficiency, emissions, and power output. Here the diagram is about fractions decreases in density and boiling point. Here is just C1 to C4 gases. The first one is 20 degrees, C5 to Cg naphtha, and second one is 70 degrees, and third one is 120 degrees. Here we to know the degrees and Celsius are increasing. First degree is 20, second one is 70, third one is 120, fourth one is 170, and fifth one is 270, and in lubricating oils, and last one is 600 degrees Celsius. The fuels and IC engines are classified into the gasoline type and diesel type and alternative fuels. The choice of fuels affect efficiency and emissions and power output. Gasoline as a fuel. The gasoline is most common fuel used in the spark ignition engines. Then we have the spark ignition ignitions are usually made in the gasoline fuels and spark plug and engines. It is a refined petroleum product with a high energy content. Gasoline volatility allows for efficient combustion in engine cylinders. Here now the diagram of gasoline fuel. In gasoline as spark plug, valve spring, exhaust valve, cylinder head, cylinder block, connecting rod, and crank pin, crank keys, crankshaft, crank, piston, wrist pin, piston rings, combustion chamber, intake valve, mixture, intake, and crankshaft, and cam, and spark plug. The next one is diesel as a fuel. Diesel fuel is used in compression ignition engines. It has higher energy density than gasoline, resulting in better fuel company. Diesel combustion produces high torque and makes it suitable for heavy duty vehicles. Diesel as a fuel is gasoline are both the same types used in compression engines. It has higher energy density gasoline, which gives you better fuel economy, and diesel combustion has higher torque and speedometer. It is for heavy vehicles and heavy duty vehicles like a truck, tipper, and etc. Alternative fuels overview. Alternative fuels include ethanol, biodiesel, and compressed natural gas. These fuels aim to reduce dependence on fossil fuels and lower emissions. The use of alternative fuels often requires modifications to existing engines. Ethanol as a fuel. Ethanol is a renewable fuel made from plant materials. It can be blended by gasoline to create E10, E15 or E85 fuels. Ethanol has a high octane rating which has enhanced engine performance. And ethanol is a fuel plant materials. It can be blended with some gasoline created fuels E10, E15, E85. Has a high octane rating which can enhance engine performance. Biodiesel as a fuel. Biodiesel is made from vegetable oils or animal fats through a process called Transfiguration. It can be used in diesel engines with little to no modification. Biodiesel reduces greenhouse gas emissions compared to traditional diesel. Biodiesel production process. Biodiesel is made from vegetable oils or animal fats through a process called transfiguration. It uses in the diesel engines and no modification vehicles. It reduces the greenhouses emissions compared to traditional diesels like an etc. Biodiesel production, it is renewable and natural domestic fuel. It also extracted from the animal fats or vegetable oils. Modify then soya bean seed and palm oil. Here it is the table. Alkali spell alcohol lipase plus alcohol transfiguration, ductile acid and esterification, and acids plus alcohol, and esters glycerol alcohol catalyst and manganese alcohol remove the separation alcohol in wastewater biodiesel glycerol. Next, compressed natural gas (CNG). CNG is a cleaner burning alternative to gasoline and diesel fuels. CNG is also used in the alternative and gasoline and biodiesel diesel fuels. It produces fewer greenhouse gases and pollutes when combusted. CNG is not able to not more pollution in the roads and highways. It is no pollution in the air. CNG requires special strong tank storage tanks and engine modification for it. It has a big tanks and specific storage to the compressed natural gas stored in the engine tanks for use. Fuel grades explained. Fuel grades indicate the quality and suitability of fuels for specific engines. Gasoline grades often include regular, mid-grade, and premium classifications. Higher grade fuels can prevent imagine engine knocking and improve performance. Octane ratings in gasoline. Octane rating measures the fuel's ability to resist an engine knocking. Regular gasoline typical has an octane rating of 87, while premium can be 91 or higher. Using the correct octane grade is essential for optimal engine performance. Next, cetane ratings in diesel. Cetane rating indicates the ignition quality of diesel fuels. High cetane ratings result in quicker ignition and smoother engine operation. Most diesel fuels have cetane ratings around 40 to 55. This is the cetane ratings in diesel. The ignition will the overall quality of diesel fuels. It will be higher, and most diesel fuels have certain rings around 40 to 55. Fuel additives. Fuel additives enhance performance and protect engine from wear. Common additives of include degradants, stabilizers, and anti-knock agents. The use of additives can improve fuel efficiency and reduce emissions. The uses of additive are more fuel and efficiency and to reduce the emissions and reduces performance and protect engine from the wear and in diesel fuel prep. Environmental impacts of fuels. Different fuels have varying environmental impacts during combustion. Gasoline and diesel contribute to air pollution and greenhouse gas emissions. Alternative fuels generally have a lower environmental footprint. Here the environmental impacts of burning fossil fuels. The pollution will be in the air and the water planting is consuming and the plants are harming. Fuels of future of IC engine fuels. The automotive industry is exploring fuels that are more sustainable and eco-friendly. The automotive expos and views are like in cars and bikes, super bikes, and etc. Innovations of biofuels and synthetic fuels and gaining attention. The future may see a shift toward electrification, but IC engines will remain relevant. Challenges with fuels. Each fuel type creates present challenges including supply, infrastructure, and cost. Regularity policies can influence fuel choices and availability. Consumer acceptance and technology adaptation are key to successful transition. Conclusion. Understanding various fuels and their grades is essential for optimal engine operation. The choice of fuel can significantly affect performance and Continued innovation is needed to enhance the sustainability of fuels used in an IC engines. To know the Here we to know the engine fuels. The automotive industries are mostly used in the engine fuels and eco-friendly, more sustainable. Innovations is biofuel and synthetic fuels are gaining attention. The future may be a shift toward electrification, but IC engines will remain relevant. In future, the IC engines will remain relevant. Challenges with fuel is each fuel type presents challenges including supply, infrastructure, and cost malleability. Regulatory policies can influence fuel choices and availability. Consumer acceptance and technology adaptation are key to successful transition. It is used to main and think the infrastructure and the cost. Understanding various fuels and the grades is essential for optimal engine operation. The choice of fuels can significantly efficient and have environmental impact. Continued innovation is needed to enhance the sustainability of fuels and IC engine fuels. Thank you.